Hello everyone, this is What's Up, and this video is Understanding the SM TPU number 1. This is in response to Giant Killer at overunityresearch.com under the final answer thread. GK, how are you doing? I just want to make a quick video as quick as possible so it takes less upload time and everything. I just made another one. It was way too long and made some mistakes, you know, with all these wires and stuff. Okay, what I want to show you here, GK, is this FTPU mock-up. It doesn't have the toroid. Now, this whole build here, the center coil, the outer rings, even the smaller windings here, this is all Litz. Litz wire. The fatter one is a 1650, and the thinner one is oh jeez, yeah, 175, number 46, 175 conductors. So this is all Litz. So my frequency generator, GK, is coming in, this one here, which is going to the two rings, these two rings here. Okay, they're turning twice, but they're also turning once, coming under, coming over, going back up, going around again. So it's like a double flip. Now basically, if you look at the FTPU, this is an analog of the outer rings that we see on the FTPU. That's your Tesla primary. There is a coil underneath in the spool of the FTPU, which would be right in there. If you looked at this as an FTPU, it would be right in there. So dimensions I don't really care about. Now, what you have here is, what I did here was, the ring here is receiving the pulse, the rings. I'm catching off of this spool here, of which is the secondary of a Tesla coil. So I'm catching off of that, and I'm lighting up this LED here. And then on these smaller, thinner ones, I'm going all the way around, then I'm going down. This is all in series. So my two outputs, I have one here, I have one output here. It's going to the center of my radiant energy circuit, which is right there. So this is going to the input of that. And the output of the radiant energy circuit is energizing this LED here. Okay, and the other side of the radiant energy circuit, I'm bringing back and putting it on one side right here. This is going right there, actually, of the load. And the difference is major, because when I take it off, when I put it on, look at that. It's just like I'm recirculating some of that radiant energy back into the load from the other side. So basically, any toroid, the toroid required in here, we'll get into that later, but right now there's no toroid being shown, because the toroid is like the final stage where everything is tied in through some very, very simple circuit with a capacitor to produce the gain that you'll be getting from both your output here and your radiant output here. Two different outputs. So these could be eventually brought back together and made this thing work in gain. But topology is what was the most important thing. How did he manage to do it? I can't see any other way. He was only going up to 60 something volts with this. So as soon as that toroid is in there with any kind of, you know, pulsing medium, he could ping this up to 60 volts very easily. There is some potential here for gain. Okay, right now the frequency that I'm driving this at is 2.88 megahertz, 50% duty. And so you can see, if I just play around with it a little more and get it pinned down, I'm at 3.09 right now. These are the this is the scope shot of the output of the center coil, output of radiant energy. Okay, so this is the FTPU. Now, what you do for the 6 TPU. The 6 TPU, you just make this wider. You make this, you see the thickness of the 6 TPU is about an inch thick. So you bring this coil out to an inch away from the outer part. Then you have your outer rings. Now this is 2 turns, it could be up to 3 or 4 turns on the 6 TPU. You can also have 2 of these verticals, 2 of these horizontals, the secondaries, one inside the other, as long as they're paralleled on each end and not in series, it should work. So you can have even 3 of these. You can have a whole thickness of horizontal winds pancaked one inside the other with an outside primary running it this way, and it'll work exactly like this. Now in the 6 TPU, the only difference is his toroid was placed on the side. That's where it was placed, and you can see the bulge actually in the 6 TPU for that. Okay, what else? So the analog of that would be, if I remove this and I put this one here instead, trying to do this without ruining anything. I just didn't want to, you see this spool is my lit spool that I brought onto there, but I didn't want to cut the line, so I just kept them in series. It still works. So I got this spool here that would be more of an analog to the 6 TPU with a wider horizontal center. Okay, that's the 6 TPU. What I like about this too, about the toroid. The toroid I don't think is the same type of toroid that we usually use. I think that, you see here, look at this. This is just a regular, like a radio antenna. And when I put it in here, I don't know if you're going to notice the difference. I can notice the difference. I'm just going to put them into these holes here. So I think the center toroid has to be a material that's like the core of this antenna here. It's like an antenna core. That's what we've got to find as far as the toroid goes. So it could be as sympathetic to this whole system as possible. I mean, these ones here, they're just way too rigid. It takes too much energy to move anything, a flux moving around here. It has to be something that is a little more passive. Okay, now let's get up to the LTPU. LTPU, outer rings. On the inside of the sidewall, he's got horizontal Tesla secondary going up here. That's one possibility. Okay, now that probably is what's happening in the taller MTPUs. Okay, but the lower LTPUs, why were they so much lower? Why would you want to have a lot less horizontal Tesla secondary? I think the answer is this. I don't think he had horizontal windings on the outside. He just used the horizontals as the primaries on the outside, and on the inside underneath, where I thought he had those 200 something batteries, he probably has these Tesla pancake bifilar coils, and you have enough room under there to put at least 4 of these with dielectric between each. Right now it's not lit, but let me just connect it up. Where are we? It's going to be around here somewhere. Yep, that's right here. I'm going to put it right there. Right now this is only the pancake coil. It's working. Okay? That's all it is. Put in 4 of these. Each one can go to their side of one side of the toroids, the 2 toroids, and because the toroids are in parallel, so you have 1, 2, 3, you have 4 wires coming out basically, and parallel the rest to your output through some caps, and that's it. The other thing I wanted to show you is this here. Okay, this is very important if you're doing anything like this. you know, where you're tanking off of the output of one side, you have to have this, okay, this diode carousel. Let me just give you some different examples. If you see that output there, this is another LED, this is another diode, another one, another one, another one, another one, another one, another type, another type. So you see each one of these is giving different outputs. The best one right now is either number 2 or number 5. Okay? And if you look here, you got your numbers identified as far as the diodes go. This is a very, very good way of finding out which diode is best for this frequency. What else? What else? What else? Oh, okay. Here's another fun part. Right now I'm at 3.11, let's say, megahertz. Let's go down. I'm going to go down in frequency. This is like 311 kilohertz. This is 31 kilohertz. This is 3.1 kilohertz. Hardly anything happening. Let's see here, around 6 kilohertz. At 6 kilohertz, I'm getting something. But with the, let's say, the FTPU 6000 kilohertz, if I put this in the middle, now I'm starting to get something that I can work with as a gain. So that's about it. So there is activity happening in this thing at 6 kilohertz. And you know, if he's saying 6 kilohertz, he could be really working it at maybe 300,000. That would be about 300,000 kilohertz. Is about right there. Yeah, 300,000 is about right there. You know, 300,000, 6 makes a nice divisible number. If you're doing any accumulation in a capacitor and discharging it, you could do it, you know, within your 60 hertz output or whatever. So that's about it, GK. Hope this gives you exactly what I'm thinking about, and this, you know, relative to your present LTPU build. There are ways of modifying it that you can get into this kind of trials. And I'll talk to you on the thread. Okay, have a good day, guy.